Hey you guys, this is Mr. Sal. Thanks for watching. This is just a quick lesson on linear equations and modeling. So don't forget to like and comment and subscribe. So this is formal point slope form, which I hate. I like mine way better. But some people like this way better, and that's all right, okay? You really get to choose between the two, except for on the homework where it wants you to put it in point slope form. Then it's going to force you to do it like this, all right? But when we do the actual solving, then you can use the other way or this way. Again, it's not going to matter, okay? So if you're given 2 points, you just have to find the slope, but then you have the option of choosing which point you want to use for point slope form. If it gives you slope and a point, then it's done deal. You only got one way to do it, okay? So find the equation of the line passing through these points, and we'll write it in point slope form and slope intercept form. But we'll always start with point slope form. In fact, this one we're going to do twice because we're going to show that it doesn't matter which point that we use to change it into slope intercept form. But first, I'm going to find the actual slope, and you guys seem to prefer the equation for that. So I'm going to make this x1 and that x2. So I've got 6 minus 5. And so this is my y1. And this is y2, so I've got 9 minus negative 4. Yeah, so we're going to change that to 9 plus 4. I mean, if you put it in a calculator, it would do it for you anyways. So I've got 13 over 1, which is the same as 13. That's my slope, okay? I guess I should write that, and that's the slope. So now for point slope form, well, it wanted point slope form, so we're going to do the formal stuff. And I said we'd do this 2 ways, which is good. So I'm going to write it both ways using both points, and then we'll solve them both, showing that it does not matter which way that we do it. All right, now what I would need to do is to distribute the 13 into both of them. Okay, so this is 13x minus 13 times 6 should be 78. And then 13x minus 13 times 5, 65. Then we have the rest of that stuff. All right, well, I want it to be y equals mx plus b, so I can't have y minus 9. And we've seen that before, right? We've got to get rid of this 9. So I'm going to add 9 to both sides of that equation. And over here, I'm going to have to subtract 4 from both sides of this equation. All right, so what do we get out of this? This zeroes out, so I've just got my y. Same with this one, so it's y equals some stuff. Hey, that looks pretty good to me. We got the same answer no matter which point we used, because the slope is the same and it's a straight line. That's how it's supposed to work, okay? Of course, you don't have to do it twice on an exam or anything, but it's a good way to confirm that you've done it correctly. For parallel lines, we need to look for 2 things in the equations. Well, actually, for both these, we're looking for one thing first, and then sometimes we need the second thing. We need to look at the slopes, first of all, okay? If the slopes are equal, then we have to look for the y-intercepts. If they're different, then we have parallel lines. That means they'll just never touch, okay? Just to demonstrate that, not that everyone likes it, but whatever. It's like taking this line right here and just moving it down right here. I'm not great at drawing straight lines, but you guys hopefully get the idea with that, right? Same slope, has the same steepness, but we've moved it so that the y-intercept is different for both of these, okay? Now if they were the same, then it would just be like drawing one line on top of another, and then they intersect everywhere, so they would kind of have infinite solutions. Not that we're really looking at that right now. Perpendicularity, this requires only that we look at the slopes. Okay, if the slopes are opposites, we're talking about positives and negatives, and they're reciprocated. Reciprocation is one of those really nerdy words we use in math. Okay, it has to do with fractions. So some of you guys look at like the number 5. Okay, as though we're not a fraction. But it certainly is a fraction. What is it as a fraction? 5/1. Okay, so how do we reciprocate that? Well, reciprocate is, I guess it's Greek for flip. I can make stuff up like that, and no one ever knows, right? Not that I'm very good with, well, any language. But it just means I'm going to flip this thing, right? And if we look, that was a positive 5, or 5/1. So to make it opposite, I would make it a negative. These two fractions are opposites, reciprocals. Which sounds pretty cool, right? So next time you guys make a band, I'm looking for the opposite reciprocals. So here we have these two lines. They're not in the same form though, which is problematic, so we need to change them into the same form. That second equation specifically, we will need to manipulate so that it is in slope-intercept form. So I can't have the y and the x on the same side. Okay, that one's considered standard form, not that we care. But I'm going to subtract x from both sides of that equation. Myself more space. Pretty close here. So this is where that y stuff comes in, right? We have a coefficient of y. Not that we use the word coefficient a lot either, but it's just the number being multiplied by y in this case. And I don't want negative 2y's, I want 1y. So how do I make a negative 2 a 1? I just divide it by itself. But I will divide it in order to balance this equation out so we don't change its value. We need to do it to all the terms. So that makes that a 1y right there. And now I've got y equals, that was a 1 right there. So it's a negative 1 divided by negative 2. That's just a 1/2 of an x. And then I've got negative 21 divided by 2. Yeesh. Negative 21 halves. We don't like fractions, but that's about all we're going to do with that equation. Because now we can see that the slope of line 1, which is already in slope-intercept form, its slope is 1/2. And the slope of line 2 also is 1/2. And then when we look at the y-intercepts, here and here, they are different. So we know that these two lines are parallel. Well, this is lines 3 and 4, though. And they are in the same form, but for some of us it may be a little bit more difficult to tell what the slope is. So let's change both of these into slope-intercept form. Okay, so same idea is we don't want 3y's and we don't want it to be adding or subtracting anything. So I've got to get rid of that 2x first by making it a 0. So I'll subtract 2x here as well. And yeah, I did leave that space there on purpose. That's a pretty good start. Now what we'll do is we'll divide all the terms by 3 so that we get the 1y, which is the same as just y. And that's a negative 2/3 x minus 10/3. Again, we worry about that 10/3 being there because it's a stinking fraction and we hate them so much. But that's all we need to do with that equation for now. So let's look at the line 4 then. All right, same idea. We got the 2y's, but they're subtracting stuff, so we got to get rid of that first. So I'm going to add 3x to make that a 0. So I'll add 3x right here as well. So I've got 2y. And now to solve this, we'll divide all the terms by 2 so that we get just the 1y. Y equals 3/2 x minus 27/2. Now we're looking at this, for some of you that really like decimals a lot, this would be a lot more difficult to tell that they are reciprocals of each other. So just to understand, fractions help us to understand better the parallel perpendicular stuff. And so the slope, so line 3 has a slope of, we can see it right here, right? The negative 2/3. Maybe I should have made that red. And this line right here, line 4, has a slope of 3/2. Uh-oh. That's supposed to be a 2. Well, what do we recognize from both of these, or we should recognize? They're reciprocals and also opposites. So that makes these two not parallel, perpendicular. There we go. Yeah, so I guess it wasn't completely important for us to know that yet. But yes, perpendicular means 90 degrees, no matter how it's situated. So on a graph, if we saw something, let's look at the axis, something like this, We can still make a 90-degree angle with another line like this one, right? But the slopes simply have to be opposite reciprocals on that, okay? So yeah, line 3 and line 4 are perpendicular. 90-degree angles are usually represented by a little box like that. Whatever's good. 9x plus 4y equals 12. A line parallel to the above line would have a slope of, well, again, some of us can know the slope of this without having to change it in the slope-intercept form. That's great because it's nice and fancy. But not all of us know how to do that. So let's change it in the slope-intercept form. So I'm going to start by subtracting 9x from both sides. So yeah, this one's going to be shown a little bit different. Well, I mean, if we wanted to change it into slope-intercept form formally, we could just flip these two, right? We just have to remember that the 9 keeps the negative with it because it's considered a negative 9x, okay? And the 12 is positive, so we put plus between them, okay? All right, and then to finish this off, we'll divide all the terms by 4, which leaves us with 1y equals 9/4 x, and 12 divided by 4 is 3. Not that that matters, I guess, because we're just looking at the slopes, okay? So for a parallel line, it would have a slope the same as the one we have, which is negative 9/4. And the perpendicular line for that equation would be the opposite. So this one's negative, so the perpendicular one will be positive, and then we're just going to flip the fraction. Positive 4/9. You don't really have to show the positive there. That's good. For the equation, negative 7x plus 9y equals negative 27, write an equation in slope-intercept form that is perpendicular to the line that passes through 14, negative 3. So, since it's perpendicular, if we can just find the slope of that original equation, the rest of it won't matter. So let's change it into slope-intercept form. So the first thing I'm going to do is add 7x to zero that out. So plus 7x on both sides. And I'll switch those right now just because we know we can. That's a 7x minus 27. And now I'll divide everywhere by 9 so that I have just the one y. So y equals, now that minus 3 is not so important because we're looking for the equation of a line that's perpendicular to this. And we see the slope here is 7/9, so the perpendicular slope will be reciprocated. So we have 9/7, but also the opposite. What this does is it allows us now to use point slope form, because they gave us a point right there, and then we'll simplify that in the slope-intercept form, okay? All right, I went back to my point slope form though, okay? So now what we'll do is distribute our negative 9/7. Okay, well now it's just a matter of combining like terms. And we do have the 18 with the negative 3, which when we combine gives us a positive 15. So the final equation of a perpendicular line, y equals negative 9/7 x plus 15. There we go. So slope in word problems is usually some kind of change or rate of change, right? Like, I don't know. They traveled 36 miles in 4 hours, okay? It's not very fast, but you get the idea. That would be a rate, which then we could replace as the slope. The y-intercept is usually some kind of starting value, initial fee, right? Like I see those signs with gyms on them, and it's like $10 to start membership. That's an initial fee right there. So that would be considered the y-intercept if we were to make an equation out of it. And then the monthly fee would be the rate, because it would be whatever it is. I don't know, $80 a month, whatever. A rate always compares two things. Very rarely are they the same thing. Okay, so like in this class, we could compare students to students not here. That's a rate because we're comparing students that are here to students that are not here, right? But usually they're different, like miles and hours, dollars and hours, boxes of cereal to dollars. leprechauns, unicorns. You see what I'm saying? Right? So it's usually a comparison of two things. A clothing store can sell 4,000 shirts for $30 each. I don't know if that's each. And 7,000 shirts can be sold at $15. Yeah, I don't think that's, this is a typo. I don't think that's supposed to be there. What is the linear equation that represents the price P of N shirts? Okay. So we do need the cost for every shirt. Okay? And it didn't really tell us the initial value, so we'll have to find that using point-slope form. Okay? Because on this one, it looks like the price is going to depend on the number of shirts sold, which means that the prices are Y values and the shirts are our X values. That's an independent, dependent stuff. Doesn't have to make complete sense, but it should make some sense, okay? So, on this one, this point, for example, would be 7,015. And then this point with the 4,000 shirts would be 4,030. Okay, so we can find the slope on this thing, right? I'm going to use 7,000 and 4,000. So 7,015 is our first point. 4,330 is the second one. And then we got 15 minus 30. That's going to give us a negative value. We got negative 15 over 3,000. That's pretty big. Let's put that in a calculator, find the decimal value. Not that we really... Yeah. So Canvas shows us the decimals because it wants us to see what the cost is for one shirt. Which, again, doesn't really make a lot of sense when we're leaving so many fractions. We're going to stick with the fraction on this thing. So, we got our point-slope form. I'm going to use mine, y equals mx, well, in parentheses, x minus x1, close the parentheses, plus the y1, okay? And we got the slope of negative 15 3/1000ths, pretty ugly. And we got x minus, oh, we get two values to choose from. What the heck, we'll use 4,000. Which is going to make that even worse. But then I've got the y value, which is a positive 30. Okay, let's distribute this into the parentheses. And just like we have with all the other point-slope forms, all we need to do now is combine like terms, right? We're looking at that 20 and 30, which combine into 50. Last year, Toy Industries made a new toy. It cost $1,800 to develop and $5 to manufacture each toy. Write the equation for the cost to produce n of these toys, c equals mn plus b. So it's just y equals mx plus b, but instead of y, we got a c. And on this one, we want the slope, which again is a rate, right? This right here is the rate, $5 for each one toy. So that would be $5 for one toy. That's just 5. Now on the exam, I'm okay with 5 over 1, but if you want to just put 5, that's okay too. Oh, n is the number of toys, right? Sorry. So it's not x, it's n. And again, we're looking for some kind of initial cost, some kind of amount that it takes to start this up. That's the development in this case, which is $1,800. So the cost would be 5 times the number of toys plus $1,800. That's our cost right there. All right, well, the second part, the cost is still 5 times the number of toys, but they told us how many toys. 4,350 toys. And then we'll add that to the 1,800. This is something we can plug directly into the calculator. There we go. So if they were to produce 4,350 toys, it would cost them $23,000. If you want the comma there, that's fine. $550. And the next part. So let's look at the equation again. And it says with 14,800 bucks, how many toys can be produced? So that would be the cost. So we're gonna put into this thing, well, 14,800. And from this point, we just need to solve for n. So I would start by subtracting 1,800 from both sides. 13,000 equals 5n. And I don't want 5 of these toys, I want just one of them, so I'm going to divide both sides by 5. And what do we get out of that? 2,600. However, and this would just be for the exam though, if you wrote 2,600, you would lose 1 point. Because it's a word problem. Toys, there you go.